I got a question asking when we use or get a substantial amount of energy from our anaerobic systems. And this can be seen in a couple places in the notes. I'm going to highlight here first this graph here. So again, when we think about the production of energy, um, during exercise, we must continually produce energy. And as we've learned, right, we have our three systems: the phosphocreatine system, glycolysis, and aerobic metabolism. And these three work together really well to perfectly match the amount of ATP required for muscle contractions to begin. As we've learned, though, that these different pathways provide a different amount of energy based on different factors. So on this slide, what we're looking at is the duration of an event. And so what we can see is that in the really short type of events, the phosphocreatine system provides right 90+% of the ATP or energy provided for the muscle contraction. Right, we've learned that system falls off really, really quickly. Glycolysis is there to kind of make up the difference and persist out to a couple minutes. And then aerobic metabolism takes place usually again in about 2 to 3 minutes when we reach steady state. And again, we define steady state in the beginning of the semester as where almost all of the ATP is produced via aerobic metabolism. Again, almost all meaning, yes, we still have some here. So one of the first takeaways of that slide that we looked at is that the anaerobic systems, both phosphocreatine and glycolysis, provide a substantial amount of energy, right, in short durations. The second slide we can look at is comparing intensity. And so this one is simply put that during low intensity or walking, we use mostly aerobic metabolism. So the lower the exercise intensity, the greater the contribution of aerobic. On the opposite end, of course, then the higher intensity we use, the more anaerobic we have. So kind of to answer the question that was posed of when does anaerobic provide a substantial amount of energy, this slide indicates that it will be during high intensity exercise. If we go to one other slide that really sums this up, we can look at it in two ways here. So when and where are anaerobic systems providing a substantial amount of energy? Again, this is really just highlighting what we just learned, right? So here we start exercise. We see in this red line from your notes that classic train that we used as the analogy, that rapid rise of oxygen consumption until we reach steady state. Well, right, just as we just indicated, before we reach steady state, here in this shaded in blue, and as I colored in red, that this half of the curve indicates that energy required or energy produced for our requirement is made from our anaerobic sources. Conversely, if we look on the second graph here we're looking at a graph that shows maximal oxygen consumption, right, or VO2 max. Right. And what we can see here is that we see that same part. So at the beginning, right, before we reach steady state, again, here's our contribution of the anaerobic system. But the second area in which we see, just as we indicated, was really, really high intensities. And in class, we have a specific word for this, and this word is that this is the supramaximal intensities. In other words, intensities that are greater than VO2 max, our anaerobic systems provide a substantial amount of energy. So again, a one-sentence summary here. The anaerobic systems provide substantial ATP at the beginning or during very short duration exercises and during very high intense supramaximal exercise.